All right, let's talk about some equations of circles. First, we'll start with these warm-ups. And the first one, a spool of thread contains 150 revolutions of thread. It means it goes around that circular thing 150 times. So that's just the circumference 150 times. The diameter of the spool is 3 centimeters. Find the length of the thread to the nearest centimeter. So we actually need to multiply by pi. So we know our circumference is 2 times pi r or pi d. Here it makes sense just to use pi times the diameter, 3 times pi. 1.5 times 2 is 3, so we could have used the radius as well, but it's extra work. 3 pi times 150, 450 pi, but we want it to the nearest centimeter. So we multiply it out, we get approximately 14 centimeters. Here, to find the shaded region, the second one, we need to find the area of the whole figure, the square, and subtract off all the unshaded parts. Well, the area of the square is just 32 times 32, 1024. The area of each circle is pi r squared. The whole length of the side is 32. We divide that by 4 to find each circle's diameter, 8. But we want to divide that by 2 to get our 4, so we know our radius of each circle. And they're all the same. So pi r squared, 16 pi, and we have 16 of them. So 16 times 16 pi is 256 pi, and we're subtracting them. We don't need it to the nearest centimeter, so we're just going to keep that answer. Then we get into the new stuff. Circle equations. X minus h squared plus y minus k squared equals r squared, where r is our radius. So this is always going to be something squared. So if we want the radius of a circle, we need to take the square root. And our center is h comma k, the second point. And it's the opposite because it's minus. The equation for r, what does it look like? Well, you take the square root. That is exactly the distance formula, just specific x's and specific y's. And what that's finding is the length of our radius, which we'll use in a second. So number one, we want to just graph this. So our center is 5, negative 1. Our radius is 4, so we go 4 each direction. We draw our circle the best we can. And we just plug in our h, our k, and our r. And remember, it's r squared, so I want it actually squared out. 4 squared is 16. Here, number 2, they give you the area. Well, area is 64 pi. Remember, area is pi r squared. So 64 times pi r squared, or equals pi r squared. You take out the pi's, you get 64 equals r squared. That's what we want anyways. We want r squared. So it's x minus 6, it's the opposite of this, plus, well, it's 0 is my k, so y plus 0, y minus 0 is just y squared, equals, and our r squared is 64. Our radius is 8 if we want, when we want to graph it, so we go 8 each way from our center. Number 3 is the same thing, except they give you the circumference. So circumference formula is 2 pi r. What that 20 is our diameter, but I want my radius, so I divide it by 2. My radius is 10, and again, I just plug it in. X minus 6 squared, it's the opposite. Y plus 4, it's the opposite of this, equals 10 squared, which is 100. We didn't graph it because it didn't fit on. Number 4, we actually changed the points all together because those points were not going to fit on our circle. So our h and k, we changed to 3 and 4, and a point on the circle, just some random point, doesn't matter what it is, negative 2, 2. So this is the new problem. So we have x minus 3 squared plus y minus 4 squared equals our radius, which we don't know yet. Well, we can use the distance formula or our circle formula, which is the exact same thing. So we plug in our x and our y into that part. So negative 2 minus 3 squared, 2 minus 4 squared. We work that out. It's negative 5 squared plus negative 2 squared. It's 25 plus 4. Root 29 equals r squared. Again, that's what we want here. We want r squared. But when we're graphing it, we have to take the decimal approximation. So it's about 5.5. We went 5.5 from their center. And we graphed it. 5 is going to be the most work we're going to see. The endpoints of a diameter, we changed it from 16 to 6, again, so we can fit on the circle, and negative 4, and negative 2, 0. So those are the endpoints of my diameter. And draw my diameter there. But I want the center and the radius. Well, the center, where is that? Right in the middle. So we use the midpoint formula, but really all we're doing is finding the averages of our x's. So averages, add two things up, divide by 2. So we get 6 plus negative 2 equals 4, divided by 2 is 2. And we divide Negative 4 plus 0 divided by 2, we get negative 2. So that's my center now. 2, negative 2. And all I do is plug it into my equation again. And again, it's just like the last problem. We have 2 points to choose from. We chose this one because it has 0. Might be easier to work with. Negative 2 from this point minus 2 squared plus 0 plus 2 squared is negative 4 squared, 16. 2 squared, 4 equals r squared, which is 20. Again, we want 20 squared here, or 20, that is r squared. So it's going to look nice in this, but if we were to graph it, we'd take the decimal approximations, about 4.5, so we want 4.5 in each direction, left, right, up, and down, drew our circle, and make sure to go through our diameter points. Number 6 is the opposite. We have a graph. We need to find the equation. So our center is 2, negative 3, just looking at the coordinates. And our radius is just 1. Look at the scale. This is 1, not 2. So x minus h squared plus y minus a squared equals our radius squared. Radius is 1. 1 squared is still just 1. And we have the opposite, x minus 2 and y minus a negative 3. So it's actually y plus 3.